We know that a quadratic in standard form is from greatest to least based upon degree. For it to be quadratic, the highest exponent has to be 2. That's just kind of basics. They will ask you questions of whether or not something's quadratic on the state test. From a graph, we know that it makes a parabola, and we know there are some key features of that parabola. There are the x-intercepts, which are our solutions, typically, which is what we're looking for. There's also the vertex, which if it's the lowest point, it's a minimum. If it's the highest point, if this is turned the other way, it's a maximum. There's obviously a y-intercept, but then there's also that axis of symmetry that cuts it perfectly in half.
Sorry, just one more announcement. Just a reminder that the last Saturday school is tomorrow from 8 to 12:30. You must be here by 8:05.
Sounds good. All right, so and then if they give us a table of data and they're asking us to determine if it's quadratic, there are ways you could technically plug it into the calculator, make it plot some points. You could probably sketch it out by hand, especially if it's already in order like this. But another way that you can tell if something is quadratic is they have constant second differences. So linear equations have constant first differences on the y-coordinates. But if I find the differences between the differences and those are constant, that's when I know it's quadratic. Now that's only on the y side. Okay. All right. The next thing we need to talk about is what the discriminant is. The discriminant, we remember, came from the quadratic formula, and it was a way to tell us how many solutions there were going to be. If we plugged in a, b, and c from the equation and we solved b squared minus 4ac, comes out positive, that means there's 2 real solutions. You have 2 actual x-intercepts. If that comes out to be 0, then there's only 1 real solution, which means the vertex is on the x-axis and there's only 1 x-intercept. If it was negative, there are 2 complex solutions. That means there are no actual real x-intercepts. Okay? In Algebra 2, you talk a lot more about those complex solutions. So now we're to the different methods for solving. So the first one was factoring, and we had a time with factoring. There were so many different ways to factor. There was GCF, there was bottoms up, there was all kinds of different ways. But we know that to factor, I have to have it in standard form, set equal to 0, and we're always looking for what multiplies to give me the constant at the end, but adds or technically sometimes subtracts to give me the middle. Once we figure that out, we find our 2 factors, and then we set each independent factor equal to 0 and solve for our 2 x-intercepts. So, what I asked you to have some paper for is I want to try one with you. So this is our example we're going to do together. First thing I would do is go ahead and put it in standard form and set it equal to 0, and then begin trying to factor. Now this one does have a number greater than 1 out front. So let's see if you remember how to deal with that. Yes, need a little boost. All right, so first thing, we needed to move that -3 over and set the whole thing equal to 0. So that would give us, that would give us 6b squared minus 13b plus 6 equals 0. So from here, there's 2 different methods. There's guess and check, where you just go ahead and set up your 2 binomials and try and see what 2 numbers multiply to give me the front, what 2 numbers multiply to give me the back, but when I multiply it back out, will still give me that middle. The other method we did was slip and slide, bottoms up, whatever you want to call it, is where we took the number at the front, multiplied it by the number at the end. So you would have had b squared minus 13b plus 36. From here, we tried to factor what was left. So we set up our 2 binomials. We know b squared came from b times b. 36, I'm looking for factors of 36 that add up to -13. Peyton? -9, -4. So from here, many of us forgot to do a specific step that's very important. Lulu? Perfect. So I do need to reduce it, though. Even if it doesn't come out to be a whole number, I still do need to go ahead and reduce it. So 9, 6, what does that reduce to? 3 halves. And then 4/6 reduces to what? 2/3. So because there's still a denominator, we did that bottoms up. This is really 2b minus 3, and this one's really 3b minus 2 equals 0. So these are the factors. If they just said factor and we needed to give those factors, we'd be done. But if we're actually solving for the x-intercepts using the factors, what I tried to show you in the past is once you're right here, you didn't need to do bottoms up because I'm going to end up undoing that bottoms up thing anyway. So once I was right here, if I'm actually trying to find the x-intercepts, I could have taken both of these and just set them equal to 0. So I could have did b minus 3 halves equals 0 and b minus 2/3 equals 0. So when I solve for the two variables here, this one, when it moves over, just becomes positive, and this one's just going to become positive. So my two answers are 2/3 and 3 halves. Now, if you went all the way and then you came back and set both of these equal to 0, you would have done the same thing anyway. I'm just trying to teach you how to kind of stop when you don't have to go further. All right, any questions about how I got those two x-intercepts? No? Okay. All right, so the next thing we learned, or one of the other things we learned, was how to solve by square roots. Square roots only work for certain kinds of quadratics. So square roots only work if there's no middle term. So for example, x squared minus 16. Or if it is set up similar to example number 2. So on example number 1, I would just have to move the 16 over, and then to undo x squared, take the square root of both sides. But you have to remember that there are two solutions. A lot of you will do it and just say 4, and then you're missing your other x-intercept. No, it's positive and negative 4. If it is set up similar to example 2, which is actually in vertex form, you would move the 14 over, divide by the 2, and then once you have that x plus 3 in parentheses squared, to undo that, take the square root of both sides and move everything over. Now some of our answers did come out clean. Sometimes we came out with things underneath the square root that weren't perfect squares, and last packet we just practiced with simplifying those again, so those skills might come back in with quadratics. So let's take a look at solving by square roots. So let's try the two examples. I'll give you enough time for both. I want you to try solving both of these using square roots. All right, looks like most of us are done. Georgia, on the first one, what'd you do?
So, I started by subtracting 7 from both sides.
Okay.
To make it just m squared equals something.
Okay.
And then I did the plus minus the square root, so that means m is -9.
Perfect. So our two x-intercepts are -9, +9. All right, Scarlett, what do we have to do with the second example? Okay, and what was -448 divided by -7? Okay, and from there, what'd you do, Scarlett? Okay, so what were your two answers? Okay, perfect. So those only work in certain circumstances. I can't use that on every single quadratic equation. Because if there was like an m to the first power or an n to the first power, this would not work out. Okay. All right, so our next thing that we come to is completing the square. So completing the square is the one that had probably some of the most steps. It is when we first moved over the constant, then we divided the middle by 2 to see what would be squared and added to both sides. Then we rewrote it as a perfect square trinomial, and then we rewrote that perfect square trinomial as a factor squared so that we could then square root both sides. So it's harder just reading. We're going to actually go ahead and do an example together because there's certain things we have to do. If there's just a 1 out front, there's one less step. But when there is more than a 1 out front, there's even more work we have to do. And if you remember me telling you, most people don't prefer this method of solving. The reason why I have to teach it to you is because they'll set up an equation and they'll solve it halfway by completing the square, and then they'll say, what's the next step? So they lock it in to where you have to know what completing the square is. So first of all, with this particular one, what should we do? What needs to be fixed here? Okay, so I need to move that 12x over, so 6x squared plus 12x. And in completing the square, where does that constant usually go? On the other side. So I basically just switched these two. Because with completing the square, your first step is usually to move the constant over anyway. Well, unless it's already there. I'm saying, if it's, because they don't always give them to you in the same format, is what I'm saying. Yes, Georgia? Yes, well, technically what we're about to do is go ahead and divide everything by that 6, and then, which is the GCF, which goes out front if you're being asked to write it in vertex form. But right now we're only using it for the purpose of solving. So those would be a little bit different. So right now, if we're just using it to solve, we can go ahead and get rid of this number out front. We're going to divide everything by it. Luckily, it goes evenly because sometimes it doesn't, and you end up with fractions. So for this case, we are okay. So we've got x squared plus 2x equals 8. Okay, so the majority of them that you run into look like this. There's not anything greater than 1 out front. Once I get to this point, does anybody remember what the next step was? Scarlett? Perfect. She just wanted to steal your thunder. But yes, this is technically b right here, the number in front of x. We always divide it by 2, get our result, and what do we do with that result?
Add it to the...
I do add it to both sides, but I technically square it first, right? But this time, what's 1 squared? It's just 1. So I'm going to add 1 to both sides. I can't hear you. What'd you say?
Why is there 6?
That's a b. I said this is b.
Oh,
Okay. All right, so we've got x squared plus 2x plus 1 equals 9. This is now a perfect square trinomial, and we were supposed to write it as just its one factor squared. So this is really x plus 1 squared equals 9. Okay, so there's two different things here. We are taking the square root of both sides, but we have to remember that there's a positive and a negative answer here. So I've got x plus 1 equals plus or minus 3. So I finished off. Where did the 2 go? In the middle? Because we rewrote the trinomial as just its binomial squared, like its factors, basically. Okay. All right, so when I minus 1 from both sides, I have negative 1 plus or minus 3, and a lot of us would do all this work and we wouldn't write this part down, and we'd make simple mistakes here. I've got to watch my signs. Negative 1 plus 3, what does that give us? What'd you say over there? Okay. And our other one, negative 1 minus 3, is, okay, so if I write them from least to greatest, our two x-intercepts are negative 4 and 2. Again, I would never actually want to solve using this method, but you do, When you get to Algebra 2, you start using it to write things in vertex form. So you do, I mean, you'll be pretty familiar with it, and you'll be better off for it. Okay. All right. So our next thing that brings us to is a quadratic formula. So to use a quadratic formula, you just need to have your quadratic equation in standard form and to be able to identify what A, B, and C are, to plug them into the formula where they need to go. And then some of us prefer different ways. Some of us try to type the whole thing in. Some of us just simplify little pieces and then work it. Some of us do part of it by hand. Whatever makes you least likely to make silly mistakes, pick that method, okay? So let's go ahead and let's try one using the quadratic formula. Ah, what is it?
Negative b plus or minus all squared plus. Wait, is it plus or minus? Yeah, don't we get a sheet?
I think it is on the.
Yeah, it's on.
Yeah. Okay. All right. So there's the formula. I'm confirming it is on your sheet. So I mean, you can sing that little song if you want, but it's on this little sheet. But anyhow, I'm going to pause, let you rearrange that and put it in standard form first, and then practice one time together using the quadratic formula. Well, I'm saying like before you get into your packet. Okay. All right, guys, let's at least make sure you got it set up right, and then let's see who of us got it correct here. All right, so we move the 42 over, so it's really 8x squared plus 16x minus 42 equals 0. So A is 8. B is 16, C is negative 42. So we've got negative 16 plus or minus the square root of 16 squared minus 4 times 8 times negative 42 all over 2 times 8. So when I generally do this, I don't necessarily type the whole thing in. You can. I usually just try to type in this part. And if it doesn't come out to be a perfect square, then you'll have to just simplify what's underneath and see if you have to break it apart. So when you type in what's all underneath the radical and you take the square root of it, did it work out this time? It came out to be what? 40. So you've got negative 16 plus or minus 40 all over 16. And so when you simplified this, what were your two answers?
Negative 3.5 and 1.5.
Definitely got it right.
All right, so Nora, how did you get such large answers? Did you just not finish dividing or something?
I did put it in, when I plugged in that last bit, I did like negative 56, because that's what I got when I did the whole thing at once. Divided by 2 times 8, so.
I got 392.
I'm sorry.
I got 392.
What did you plug in? You plugged it in correctly?
Whoa.
392. Okay. Well, what's underneath the radical? When you just put all that in, you come out to get just 40. So you got negative 16 plus 40, which is going to be like subtraction divided by 16, and then negative 16 minus 40, which is a negative 56 divided by 16. How did you get such large numbers? Did you mess up on your signs, plugging them in or something?
I don't know.
That could be it. All right, guys, when we get to these one-on-one, I'll kind of come see the way y'all are typing it in, but for the sake of review, we're going to move on. That's what you should have gotten. Okay, so the last thing that I come to is plugging it into the calculator. Now, I'm not going to even attempt to do this on the screen with everyone at once because it's mayhem every time we do. I went ahead and I put in Schoology a video of someone walking you through, step by step, finding the x-intercepts in the calculator. So if you would like to do that, you are welcome to watch that video and try. Before we move on together, I would like to also just talk about other things in the calculator. Finding a maximum or a minimum for a quadratic. That's second trace either max or second trace min. Finding zeros. Second trace zeros. A lot of these things are at second trace. Absolute value on that practice test, a lot of you kept forgetting this. To do absolute value, which you don't really need necessarily right now, second zero enter. resetting the calculator. Hopefully we all know that. 2nd plus 7, 1, 2. Okay? So at this time, you can go ahead and begin working on your packet 6. Our quiz on packet 6 is next Wednesday. So you have until next Wednesday to finish this. Yes, Scarlett? I am coming.